Yeah, drop, hey, huh.
Yo, what's up guys, this is 𝗪𝗥𝗟𝗟 and today we're playing Assemblers Avenge from Hack the Box. So this is actually a challenge I made for DEFCON CTF, I think 2024, 23, something like that. And we have this zip file, unzip it, hack the box password, alright, and let's run it. So when you stare into the abyss stares back at you. Your only savior is 𝗪𝗔𝗧𝗖𝗛, so that's tricky. We actually have a 𝗪𝗔𝗧𝗖𝗛 string there. Let's see. And the program seg faults, okay. And let's see, we have, oh my god, a 64-bit executable statically linked, and inside the debugger seg we see that we have nothing, no error, no canary, no pi, an X. That's really nice. That means I can probably have left some unintendeds in the way. Info functions, we see that we have some custom write, exit and read. Okay, let's do Disassemble. Right, and okay, we see that's an actually legit write call here. It prints a message, and after that let's inspect read. This seems like a nice read function, write syscall, but actually we can see that there is a buffer overflow here because it subs from rsp0x10 and then it reads to rbp minus 8 rdx, which is the third argument of the read function. It reads up to 0x18 bytes, that means we have a slight buffer overflow here. And last but not least, let's take a look at the exit function, exit syscall. And right here we see, okay, this looks like a normal exit syscall, but in the end there is a jump RSI gadget for some reason. And let's also try and let's make a cyclic 50 and we run the program, we crash it. First of all, we see that our buffer overflow offset is at 16 bytes right here, and we also see that it is stored inside RSI. This is really important because, as we saw earlier, we have a jump RSI gadget and our payload is stored inside RSI. From the check sec we saw that NX is disabled. That means we can actually overflow the buffer, overwrite the return address, and jump right to RSI where we have stored our shellcode. The issue here is that we only have a limited size payload, which is 16. The smallest already existing shellcode I found, I think, was like 17 bytes, 23, I don't remember, but it couldn't fit here. And at this side we can see what, here we see the syscalls, and we see what the register should be in order to do the syscall. We see that racks should contain 59, here RDI should be the address of 𝗪𝗔𝗧𝗖𝗛, and RSI RDX should be null. So let's start and craft our payload. Here's my pawn template. If you guys wanna find this, I will leave the video in the description where is my intro to binary exploitation, and you can see I have made a helping hand GitHub repo where I explain this stuff. So let's go here, Assemblers Avenge, and right here we don't need this, we don't need that, and we actually don't need anything here. What we need to do though is call execve 𝗪𝗔𝗧𝗖𝗛, and how to achieve that, we need racks to contain 59, we need RDI to be address of 𝗪𝗔𝗧𝗖𝗛, we need RSI to be 0, and we need RDX to be also 0, and then do a syscall, and all the above are stored inside RSI, so we actually need to use the jump RSI gadget, and we have jump RSI is at what was the again next? Okay, so we have the address of jump RSI here, like this, and our shellcode should be something like assembly And first of all, we need to, let's clean these registers. XOR RSI, RSI, RDX, RDX, and then move AL. AL is actually the lowest byte of RAX, just the way you see it here, it's 40, this 40, the last one on the right, and here we need 59, and after that we just simply do the syscall. So we have this cell code so far. We can also print the length of this cell code. Len of cell code should be len of cell code, and then we have our payload, which should be, if you remember, we found the offset here to be 16. Cell code 𝗙𝗢𝗟𝗟𝗓 until we have 16 bytes, and then we're gonna use some knob slides like this, and then we need the jump RSI gadget, 𝗪𝗘𝗥𝗘 payload, and 𝗪.interactive here. That should give us cell, but here I forgot to do that. We forgot to put into RDI the address of 𝗙𝗘𝗥𝗘, and there are two ways to do that. Let's go here, move EDI, and I'm gonna have the address of 𝗙𝗘𝗥𝗘, which is the address 𝗙𝗘𝗥𝗘. The first way to do it, the manual way, is if we go here, search 𝗪𝗏 string, and have 𝗪𝗘𝗥𝗘, and we see that the address of 𝗪𝗏 is this, and the one I prefer is the dynamic one. Next, e.search 𝗪𝗏 string, and as we can see, we have actually managed to craft our cell code stored inside RSI and then jump to RSI. And let's put it into action. Python solver ID, and we see that we actually managed to get cell. Let's also try and do that remotely. We go here, we start an instance, we take that Python solver, and we take the IP and port, ID, ls, and we see that we actually managed to also get cell remotely. My intended solution was to craft your own assembly and not rely on some already existing on the internet. And I hope you enjoyed it and learned something from it. If so, leave a like and subscribe to the channel to support me. So have fun and see you in the next video. Bye!